Okay, so let's practice factoring now. This problem's been mostly done for us. So all we have to do on this one is factor out the greatest common factors in the area model to finally finish factoring this expression. So our greatest common factor here is 3x. Our greatest common factor here is also 3x. Here it's 4, and here it's 2. 3x times 3x is 9x squared. 2 times 3x is 6x. 3x times 4 is 12x. And 2 times 4 is 8. And so now we can actually write the answer in factored form. 3x plus 2 from right here. The 3x and the positive 2 is 3x plus 2. And then 3x plus 4 from right here. So this is written out, and then this is factored form. We call this written as a sum, and this is written as a product. We have two things multiplied together, 3x plus 2 multiplied by 3x plus 4. So let's look now at one that's been partially done for us. Here we're going to have to do the diamond problem. The diamond problem and the area model were set up from the original problem. Let's actually look at that on number 1 here as well. So the 9x squared and the 8 need to go diagonal from each other, and you can put them here and here or here and here, it doesn't matter. And then the 18x went right here. Then you multiply these two, the 9x squared and the 8 together, to get the 72x squared. And then you would solve the diamond problem, and then you can finish. So let's look at number 2 again. The x squared and the negative 7 again go opposite in corners from each other. Could go here and here, could go here and here. Multiply those two together to get the negative 7x squared that goes up here. And then the negative 6x goes right here. So hopefully you're okay with diamond problems. If you need to go back and watch the video on that, you can. But we're multiplying to get what's up here and adding to get what's right here. So that's negative 7x and positive 1x. Then whatever you get in those two boxes goes in these two boxes. And it doesn't matter which one goes in which, just the two empty boxes that should be kitty corner from each other. Then we can pull out our greatest common factors in every row and every column. Just double check x times x is x squared, negative 7 times x is negative 7x, x times 1 is 1x, and negative 7 times 1 is negative 7, just to make sure that it works. And then we can just write our answer here in factored form, x minus 7 times x plus 1. So this, factored, is x minus 7 times x plus 1. Okay, here's another one. You can maybe pause it and try it yourself if you want. Again, these two, 2x squared and 5, are written opposite corners from each other, kitty corner from each other. So we're going to multiply those two together and get 10x squared. And then right here, the negative 7x goes right there. That's going to be negative 5x and negative 2x. And we write those here. It doesn't matter which one goes in which box. Now we do have a problem here the way I've written it, because these are both negative. This is not negative. But if we change it so that our numbers that don't have the x's are both negative, it should work out. X times 2x is 2x squared. Negative 1 times 2x is negative 2x. X times negative 5 is negative 5x. And negative 1 times negative 5 is positive 5. So this is x minus 1 times 2x minus 5. We're just going to try a few more. So on this one, the 2x squared and the 40 go in opposite corners from each other. Then multiply those together. That's 80x squared. And then the 18x goes right here. So we need to find two things that multiply together to be 80x squared and add to be 18x. That's 10x and 8x. We'll put the 10x and the 8x over here. Again, it doesn't matter which one goes where. And then we'll just start pulling out our greatest common factors. So this factors to be, but sometimes that doesn't quite work. And the reason that is because there's more than one way we could have pulled stuff out here. 2 goes into 2 and 10. 2 also goes in to 2 and 8. And so I didn't actually factor this completely. You can see right here, 2 and 8, 2 comes out of both of those, which would leave me with an x plus 4. So completely factored, this is going to have this 2, x plus 5, and x plus 4. So let's look at a better way to do that problem. A better way to do that problem is to recognize in the beginning that that greatest common factor, that 2, is going to factor out of all of those terms from the beginning. All of these are even. All of them are going to divide evenly by 2 to start with. So that's going to be 2x squared plus 9x plus 20. There we go. Now you can see that. So now we need to look at this and not worry about the 2, but do our area model and our diamond problem. But just with the stuff in the parentheses here. So 4x and 5x multiply to be 20x squared and add to be 9x. And then we can't forget that we pulled that 2 out in the beginning. So that 2 is still part of our answer. We have x plus 4 and x plus 5. It's the same thing that we got over here. Maybe you can zoom out just a little bit so you can see both of those at the same time. They're in a different order really, but that doesn't matter. It's still the same thing. X plus 4 times x plus 5 times 2. Those are our 3 things getting multiplied together. And so that is our correct solution on that one. Okay, go ahead and try one more. I'm going to go through it. If you want to keep going through it on your own, go ahead and pause the video. And that's how we factor that one. We get x minus 8 times x minus 3. Another good thing to remember on factoring is you can always check your work. You can distribute, or you can multiply these back together to check your work. You can even use the area model. You could write the x minus 8, maybe I'll even do it, with a new area model, and x minus 3, and then multiply all of your pieces of your area model together. And then just combine like terms. Negative 8 plus negative 3 is negative 11. And if that gets you back, oh, you can't even see what I did there. There it is. If that gets you back to what you started with in the beginning, which it did, then that means you probably factored it correctly. The only way it wouldn't be is if you did your distributing wrong. So if you distribute it correctly and get back to what you started with, then you factored it correctly. Alright, I just have a few more problems for you to practice with. So you can go ahead and try these. Pause if you want to. I'm going to do these real quick and then you can check your work. So now I've got all of my work and my answers here, so you can just check and make sure that you did everything correctly. If you didn't, go back and kind of fix your work. Don't forget that you're multiplying to get to the top of your diamond and adding to get to the bottom of your diamond. Then these two go over here. And you just want to double check x times x is x squared, 8 times x is 8x, x times negative 4 is negative 4x, 8 times negative 4 is negative 32. Make sure all those things work out, and it should be good. Okay, so I've got just 2 last problems here for you to try. So go ahead and see if you can do these 2 problems. Alright, so I've got my answers on here. Did you notice on this one that everything could divide by 3? So we could divide by 3 in the beginning, and then we had these smaller numbers to put into the area model on the diamond problem. If you had done it with the bigger numbers, it would have been a little bit trickier because the numbers are bigger, and then you would have had something in the end where you could have divided out this 3. But you should have 3 and x minus 6 and x plus 5. Also over here where it's just a negative x, you do have to remember that negative x, sometimes it helps to put the negative 1x in there, so you know that there's 1, negative 1x. And then our last one here was 3x minus 4 times 2x minus 1. So hopefully that kind of helped you get a better idea of how to factor.